Hello, everyone, and thank you for joining us today for Standardizing Configuration Management in your hybrid cloud with Puppet. We have two speakers joining us today. Daniel Wittenberg is a senior technical architect at AHEAD focused on configuration management technologies. Daniel is also a certified Puppet consultant with 10 years of experience using Puppet and over 20 years of experience in the IT industry. Today, Daniel will be giving an overview of AHEAD's cloud delivery platform and how configuration management with Puppet fits into this solution. James Jones is a technical solutions engineer at Puppet who focuses on building out DevOps-oriented solutions with Puppet Enterprise. Today, James will be going through an introduction to Puppet Enterprise and how it helps organizations get a handle on their servers using configuration management by running through base OS configuration and web server development. Now let's get started. Dan, take it away.
Thanks, Chelsea, and thanks everyone for joining today. We're continuing our hybrid cloud webinar series. Today we're going to focus on config management with Puppet. We're going to give a quick recap of the AHEAD cloud delivery platform, which is how we build hybrid clouds and kind of the tool sets and methodologies that we use. And James is going to give us an overview of Puppet as well as some demos, and then I'll wrap up with a hybrid cloud demo, and then we'll both be available for any questions. With that said, let's jump into the delivery platform. So starting with 2016, we really wanted to align our methods and procedures with that of how our customers operate. And so we really wanted to help them simplify their IT, accelerate service delivery, and increase transparency. The real goal is to be able to help provide the critical applications and services while still taking into account the enterprise service management, the cloud management and automation, mobility, and the data center infrastructure. So why are companies going down this journey? What we typically see is a lot of the older processes where you see this request going around from group to group and people to people, sometimes minutes, sometimes days, sometimes weeks. And as you start to move into a cloud, you really want to accelerate that. So a lot of companies are starting to look at that direction to how to simplify. So what do we mean by cloud? We hear this term a lot today, but what does it really mean? At AHEAD, we don't just look at it as a public cloud, but we have kind of three distinct service models. So we have the cloud, lifecycle and management, the orchestration, and the config management. So the orchestration, we normally see like the vRealize or UCS Director, and then config management with Puppet, where we're going to be focusing today. Okay, so what is config management? Change management is a big part. Most companies have some kind of form of managing their change. Some are still kind of manual processes, some are kind of automated, but usually we try to look at how we can use config management to help that process. Then release management. Most software development companies have some kind of release management, but maybe not utilizing config management to help streamline that process. And patch management, something about every company has to worry about. So how can you leverage config management to help keep things patched and updated? And compliance. Many companies today face some type of compliance or regulations, and how can you be sure that you're in a compliant state? How you'll be able to show that to auditors? How can we use config management to help with that? And security. So something else pretty much everybody has to worry about these days is keeping all the devices and all the virtual machines in a secured state. And it can be a big challenge without any kind of config management. So the ultimate goal is to be able to build out these modules, kind of like building blocks. So we have like the Windows team can build out their base OS, Linux team kind of builds out their base OS, then the different application teams can build out the different applications, since they're the real experts in those. And once we start getting those together, we kind of build them together as building blocks. So here you see kind of an example of building a base OS with a SQL server and then layering on security from there. So here we have our AHEAD reference architecture, which we've updated this year. Kind of gives you a broad overview of how the kind of application stack works. So we have our customer portal, which is usually where you log in to request your various tasks or get the services. Then you have a service catalog, which will actually give you the items that you can request, or VMs, or any kind of various services. Then you have an orchestration and process automation layer. This is really kind of where you start the back end of things. It starts coordinating all the services and requests that you're asking for. And then we'll see under that is config management, where Puppet ties in, and this is where you get a lot of that work done, especially when you're standing up VMs. So you also have some other things in there that orchestration helps with, like lifecycle management, capacity management, the monitoring, chargeback and showback, and then you have some of the back-end infrastructure from there. So you'll see like the VMware, the Cisco hardware, or you can even go to the public clouds like Amazon and Azure. So what does it really look like, and what do you see? This is an example of the AHEAD Aviation Service Catalog, which is our fictitious company that we use for demoing new applications and services. Here you can kind of see the buttons for all the different types of virtual machines and services and apps that you can deploy. And so the end result is kind of where we're looking for. So in the example here, you'll see that the request for a SQL server kind of just moves from service to service, setting up our infrastructure, taking a few seconds, maybe a minute or so per item, as it goes along from item to item until it finally hands off to config management, where the real work of getting everything set up happens. And when it's done is where you end up with your SQL server with your application configurations and security and everything layered on top. So configuration management has really changed in the last 20 years since I've been in the industry. It started off being a lot of manual work. Then we kind of wrote some scripts to kind of help out various pieces. Then we tried different ways of automating those scripts, and now today we have fully automated solutions like Puppet that will really get us to a hands-off solution where you can push a button and get pretty much any kind of device you're looking for. So one of the questions that I hear a lot is where to get started. One of the first things I usually tell people is grab the learning VM. It's got everything to really get started and get you up and running with very minimal overhead. One of the next things I tell people is to go find your local Puppet user group or your local pug. There's a lot of good people with a lot of experience that can answer a lot of questions, point you in the right direction, even kind of help with some of the code if you need it. And then start simple. Just kind of build your foundations first. Don't try to boil the ocean. So don't try to imagine implementing your entire infrastructure at once or every application or all the security. Break it down into those smaller pieces. And definitely check out the Puppet Forge. You don't need to reinvent the wheel because there's tons of modules out in the community. I think there's like 4,400 last I saw. Quite a few of them supported by Puppet itself, so you can be sure that they're good and they work. And so once you get a good foundation, then you can start to build out the things that really matter. So from there, I'll hand it over to James for a little more review and some demos.
Great, thanks, Dan. So to talk a little bit more about, kind of where to start. A lot of times when we're really getting people started with Puppet, the thing that we start to focus on first is really nailing down that core infrastructure. As Dan was speaking about earlier, Puppet is a declarative language for modeling system configuration, and we really allow you to just focus on building up these individual building blocks of configuration state, and you can think about the end state of what you want these pieces to look like. So you would start with things like NTP, basic operating system configurations, SSH, firewall config, and as you start to really nail those down, you can begin to move up the stack. So then start moving into your application infrastructure, and you can have that with the confidence of knowing that your base OS image is going to be consistent and deployed in the same way each and every time. And so you start to build up these layers where it becomes easy to attack more complicated problems like provisioning, whether that's bare metal or virtual environments, or even if you need to do orchestration across multiple nodes, where you maybe need to connect a web server with a DB backend, maybe configure a load balancer on top of that. Once you start layering each and every one of these individual pieces, reaching that end goal as the eventual end state you have it completely modeled for all of your applications becomes something that's very attainable. And so when we approach this with Puppet, this is something that you can do across all of your devices and all of your different operating systems. So, whether it's a Windows machine that you're looking to configure, a Linux box, and network switch as the example with Cisco Nexus products, or if you're even trying to do a cloud deployment, either local with a vSphere instance or with AWS or Azure, you can know that Puppet is going to work the same way with the same language across all of these different device types, so that you have a common language that you can communicate with the rest of the members of your team to be able to get configuration management done. So to actually get into a little bit of the details, I'll step through a couple of technical slides on how Puppet works, and then we'll get into the actual demonstration. So when starting with Puppet, as Dan talked about earlier, we really start with a model-driven approach, and we try to make it so that it's very modular. So you can see this first step in what you're typically working with Puppet is going to be defining what you want that desired end state of your machine to be. And we do this with these individual building blocks called resources. This one that you see here is an example of a service resource for NTP. We want to make sure that the service is running. We want to make sure it's enabled at boot time. And then we also want to map a dependency to its ntp.conf file so that Puppet knows to restart that service if there's ever any changes to that configuration file that it's dependent upon. And so you'll combine these various resources together with other things, maybe a few users you need to manage, maybe an overall application that you need to deploy, and you'll just build these all together to reach the overall configuration end state of that machine that you want. And after you do this, since we take a very declarative style to doing this configuration, as you can see in the code, it's just based upon key value pairs versus the individual steps that you need to take or commands you need to run to get to that end state. We built this all on top of an abstraction layer. And that gives you the ability to do something that's really unique to Puppet in our approach to configuration management, because we take that declarative approach, where you can actually simulate what you want to have happen on your machines before you actually change the configuration state of that box. So I can actually run with this definition simulation and test against what my Puppet code would do to my machine, so I can see it in a test flight if there's going to be any issues with my deployment going forward, if it's doing the things that I expect. And it really gives me that ability to have control over my environment, exactly when changes are going to happen, what sorts of changes are going to happen, and even being able to verify that the changes will happen the way that I want to before I even do it. And after you have that all verified, you have the ability to then enforce those configurations, which is the default state that Puppet actually runs in. So every 30 minutes, Puppet will check into the Puppet master, get its definitions that are supposed to be applied to it, check what its end state should be, and then apply that, and then give you a report back with details resource by resource as to what maybe was changed, or if everything was actually in that compliant state based upon your definitions. So we really wanted to make it so that you have complete visibility and insight into how your infrastructure is working and set up. And so Puppet really gives you the ability to do that in case you want to use this for compliance reports or to make audits a little bit easier to get through. So to talk about how Puppet works in the background, there's two major components to how most Puppet setups work. And that's going to be the Puppet agent, which lives on the node that you're looking to manage, and the Puppet master, which is going to be where your various code as well as Puppet infrastructure will be living. And so how Puppet works, it's all in the pool-based model, where the node will generate some facts or inventory information about itself. These facts would typically have information like what data center I'm in, what's my network configuration look like, what's my host name, what operating system am I, and this can be customized with other information like maybe what role this machine should be or other information like that. And this is really a common integration point for if you're using a cloud provisioning environment like Dan was speaking of, like a vRealize, you can have that integrate directly to create facts on a node so that when a Puppet agent reaches out to the Puppet master, it knows exactly what to configure itself as. So the Puppet master will take those facts and combine it with those definitions we spoke about on the last slide and generate something that we call a catalog. And this catalog will be unique and specific for each node in your environment. So it's going to follow a security model of least privilege, where each node will get only the information relevant to how that particular machine should be configured. And based upon that, the Puppet agent will start applying its configuration for that machine. After that, the Puppet agent will report back any changes to the environment to the Puppet master, where it'll be aggregated, where you can do reports for the overall status of your entire infrastructure or just that particular machine. And that can even be exported out to other third-party tools if need be. So with that being the case, I'm going to go ahead and jump out of the presentation and actually run through a demonstration for you guys. So right here, I'm flipping over to my actual Puppet Enterprise console. This will be the main way that you actually utilize Puppet in most environments. You can see here on just our overview page, getting a quick snapshot of what the status of my environment looks like. I have 3 nodes here under management. Right now, there's not any changes that happened on their last check-in, so I know my machines are in their compliant state. If I click on one of my nodes here, I can see all of those facts that are reported back by the Puppet agent around that particular machine's configuration. You can see here hardware information, information around network devices, host name, all of these sorts of details. And this is something, again, that can be customized with your own scripts or static data, or characteristics like what data center machine's in. And I can start to use this to be able to actually group nodes by like configurations. So if I wanted to create a group, such as we can see here, different groups that I have set up for different servers in my environment, I can start to tier them, like having a parent group of my Linux servers where I have all of my Puppet code that I want to have applied to every Linux server in my environment here, or something for my Windows servers, or even if I have another one like a subgroup like my GitLab servers here, I can create that as well. If I click on my Linux servers here, I can see that I'm determining what a member of this group should be based upon a couple of different facts. If it's a Linux-based kernel, if it's not my master, it will automatically be added here. So as soon as I get finished provisioning a system from something like a vRealize, I have the ability to automatically have that node check in, be part of my Linux servers, and get its baseline configurations right out of the box. Similarly, I can statically pin a node, or choose any of the other facts that are available in my machine, even custom ones that I create, and do operations like regular expressions to be able to get there. So I can see which servers match, and based upon this, I can start making changes to all of my Linux servers configurations. So I have some baseline profiles already added here, one here for NTP, some other ones for root environment, Vim environment, other such baseline configurations. But what I'm going to do in this first example is just change this configuration for my servers and change the server that I'm connecting to for NTP. You can commit the change here. And then based upon this, all of my Linux servers, the next time they check in, within the next half hour, we get this updated config. But let's say before that, I wanted to actually do a test run and just see what this change is going to look like. What I can do is with no-op, which is what we call our simulation mode, I can test to see what exactly this change would look like. And so as Puppet runs, we can see that there's going to be some changes to my ntp.conf based upon that config change. It would remove my old server entries, add my new one that I just specified, trigger a service refresh so that that change actually takes effect, and then I would be back in my compliant state. So I'll go ahead and get rid of that now that I know this is what I actually want to have happen. I'll run Puppet. And it's going to make those exact same changes for me, restart the service, and now I'm in my known good state. And I can run Puppet again over and over again. There's not going to be any additional changes made to the system since it's in that good state. So Puppet has that idea of being able to keep track of when it needs to be making changes and when not, and this is what really separates it from just manual scripting. But as soon as I make a change to my config file and add some broken data here, I can run Puppet again, and it's going to immediately catch that node that there's a drift event that occurred and bring it back to its compliant state. And so this is something that Puppet can do regardless of whether it's the first, first install of that machine, first setup. It can make sure that everything is set up and configured and provisioned the right way. Or if it's day 30 or day 60 of that machine's operation, it can just police that machine and make sure that it holds it to that right configuration state. So this isn't something that's unique to Linux. If I switch back to my master here, switch to the servers, and actually add some code here for managing time servers on Windows, could do the same thing there. Then switch over to my Windows box. And using the same commands, using the same language, Puppet works the exact same way. It's going to check into my master and then make sure it makes the appropriate modifications to my system to get this Windows machine in the right state. So the reports all come back in the same exact way. We can see there's a couple of registry keys that need to be modified in order for that to take effect. Service needs to be restarted just like on Linux. But it really allows you to just model what that end state should be without thinking about what the nitty-gritty details of commands need to be run in order to make those changes for you. So Puppet is going to, at the end of that, give you back detailed reports of exactly what happened. If I go back to my overview page here, we can see a couple of servers were modified. If I go to the last run report for these, I can click here and I can see the raw output of those particular modifications made to my system. You can even see the line of Puppet code that caused that change, giving you auditability back to maybe even your version control system. You wanted to find out who authorized a particular change. That's all something that can be easily tracked. And then if I go to my events here, I can see all of the resources that are managed by Puppet, including ones that weren't changed on that last run, so I can know that everything was in the right compliance state. If I want to filter to just the ones that are changed, I can see that here, and I can see the registry keys that were actually modified. So with that being the case, Puppet can do a lot more than just base OS configuration, and that's really something where the Forge becomes an important piece of your Puppet deployment. So the Puppet Forge is an online content repository for pre-written Puppet code. It allows you to browse around through some modules that have been created by Puppet Labs, as well as some that are created by the community as a whole. So we have two programs here. One are supported modules. These are going to be tested against Puppet Enterprise. You can receive support for these just like any other part of Puppet Enterprise. And then we have our Puppet Approved Modules program, which are going to be ones that we've kind of vetted and given the stamp of approval as good modules, well written. They usually have developers that are responsive and good in general at developing their code following our best practices. So it's a great place to start. So just to give you a couple of examples, if I look here at my Apache module, I have an easy way to manage an installation of Apache. All I have to do is add this line class Apache or include Apache, and then I can have Apache installation actually performed on my Linux box without having to worry about what the package name is, what distribution, what package manager I need to use. That's all handled by the abstraction built into Puppet. And then if I go below, I can see some examples of setting up a vhost, where I only have to worry about the key value pairs that I want to modify. Port 80, the document root should be var www vhost. So I don't have to worry about exactly where the config files are for making these sorts of changes. Again, just key value pairs written just like a config file for exactly how I want to be making these changes on my system. Similarly, if I'm doing something on a Windows machine, we can take a look here at our SQL Server module that's available. If we wanted to set up something like a SQL Server instance, you can see we just give it a name, provide it with some details, including the source of the installation media. And really, I'm just defining what I want that end state to be. I can say what features I wanted to install. If I wanted to find a couple of logins, I can do so. And it's all in that same language, just again on key value pairs. But beyond just doing standard applications that you install on a server, we have here an example of doing provisioning on AWS, where you can specify something just like an EC2 instance in that same Puppet language, specify what region it should be in, whether you want present, what AMI it should use, what instance type. And that's also something Puppet can manage in the exact same way, focused on the end state, whether or not you want that particular instance to be present or absent, whether you want it running or not. And Puppet can do that all within our simple-to-use language over Amazon Standard APIs. So to go through an example of a little bit of a full deployment of an application, I'm going to go back to classification here, go to my Windows servers, go to classes, and then I'll just do a deployment of an example website. So actually, I'll create a new group for that. Let's do parent of my Windows servers. So I'm creating a subgroup here. Go down. And then I can just statically pin my Server 2012 box to that. And I'll add my Puppet code for my typical website deployment. And this time I'm going to go ahead and kick off the actual Puppet run from within the Puppet console. So I can click Run Puppet, have the same options to run it in simulation mode or just do it right here from the UI. And now Puppet run is in progress, and it's going to make sure that my website is deployed based upon my definition. So the great thing is, regardless of whether I'm doing this on one machine or if I added additional servers to that group, I wanted to have more servers built the exact same way every time. It's as easy as classifying additional servers as part of that group, and Puppet would build it out in the exact same way. So while that happens, it takes about a minute for this Puppet run to complete, install IIS, make sure the application is deployed, etc. I'll go ahead and show a little bit more of some of the reports that we're able to see here. So one of the more interesting ones is, if I look at this CentOS box here, we have a new feature called the Node Graph that allows you to see how Puppet is visualizing all of these resources and how they're related. So I can see visually if I wanted to see that ntp.conf file, if I wanted to see where that was in my code, I can see it was recently changed. And that definition is based upon this ntp config class that I have. And if I can see some details around exactly where that's defined. But I also have the ability to see dependencies of that particular class as well. So if I'm ever wondering if there's multiple people working in my org, they're developing code independently of each other, and I want to see who I'm going to be affecting downstream from me or upstream from me, I can see how all of those dependencies are related, and this becomes very handy for any sort of troubleshooting you might need to do. Additionally, if I go to this Events tab, I have the ability to filter within a particular period of time. Instead of going to each individual node and seeing the state of things, I can see within the last 30 minutes what things have been changing in my environment. So if I wanted to just see classes with changes, I can see these ones that I was just recently using, which ones have caused change in my environment, or if I want to just see which nodes have had change, I can drill in and start to see more specifics about exactly what changed, when it changed, why it changed, and so again, just giving you visualization as to what you need to keep track of there. So if I go back to my main page, it looks like my deployment is all finished. If I click on that run report, I can see that my IIS Windows feature was added, my generic website was deployed, can get some information about that. But the important thing is I can just go over to my box. I can see that IIS has been installed for me and that my site is ready to go. So if I wanted to just do a quick browse to that, I can open up my browser, actually check it out, and it's ready to go. So we have my example little Puppet website here, ready to go, and if I ever needed to add more nodes, it's just really simple to do, the same Puppet code. So with that, that's just a quick demonstration of some of the things that you can do with Puppet. And I'm going to hand it over to Dan to do some additional demonstrations of how you can take that a little bit further with vRealize.
Okay, so here we see vRealize automation. We're using this as our service catalog, kind of we talked a little bit about earlier. So lots of different kind of services and things we can request. Here we're going to look at a specific application that we wrote for our fictitious company. This is a baggage handling app. And so what we've got here is we've actually got one application that we can deploy either on-premise to VMware, or we can deploy it to AWS. Same Puppet code, both places. All we have to do is go in and say request. And we just pick an instance ID. Let's pick one. And everything else is kind of preset, so we know how many CPUs and memory and everything that it needs. Hit submit, and it goes off, builds some service for us. Along the same lines, we want something for AWS. We can just go in and do another request. And again, we'll take a different instance ID. We do have a little bit more information to provide to AWS, so it knows which exact subnet and everything to put it into. Since we can deploy to a lot of different data centers and a lot of different environments. Hit submit, and it goes off and builds. Now, for the sake of the time, this does take a few more minutes because this is actually fully provisioning the VMs and not just deploying to already there. We actually have a couple that we did earlier. So you can see we have a standard on-premise one where we see the two VMs, the web server, the database server, and the VLAN that connects them together. And then we have our AWS app. You see the two instances that it provisions, so the app server and the SQL server. So our on-premise app all looks the same. We can run through the app, and for AWS, looks very similar. Same exact app, same Puppet code. We'll look at the console here real quick, and you can see that our nodes are actually out here in EC2. So there's 516 and 517 that we deployed. And kind of looking from a Puppet perspective. So these nodes look just like our regular nodes in the cloud. They look and manage just the same. We can go through and force the Puppet runs on all of them. You can see the reports and everything. So the way these are all tied together, it doesn't matter whether it's on-prem or EC2, all managed and look the same. And again, just a quick look, it's all the same code. We don't have anything different for running in one environment or the other. It's just the orchestration engine understands that, oh, for VMware, I need to do one thing, but in order to deploy to EC2, I need to have different credentials and different configurations. Let's jump back. So we're going to talk a little bit about the partnership between AHEAD. One of the things that AHEAD has is our lab and our briefing center. And our lab actually contains a lot of up-to-date and emerging technologies across all sorts of the data center to give you really a hands-on experience with many different products and solutions. A lot of the briefings that we do are with customers that want to see things, how they would look in their environment. And we typically have about 3 different kinds of briefings. One is a technical briefing, which is about 30 to 90 minutes. So an AHEAD certified expert will be there to kind of help talk about some of the new innovative solutions in the industry and how they might help you get whatever problems you're having solved. We usually have like a solution briefing, which is 3 to 4 hours led by a solution expert. Well, they'll look at a lot of the different technologies, kind of review your environment, what's the state of the marketplace, and kind of help explain some of the capabilities and benefits of some of the new solutions. Then we have an executive briefing, which is usually 30 to 90 minutes long, led by one of the AHEAD's executive team and really geared toward your leadership team. So we'll walk through a lot of the major changes in the industry and some of the new innovative solutions and see how it can really help transform and optimize your current solution. AHEAD is also a service delivery partner, so we can help you with any of Puppet's products. We can help deliver services, and we're actually getting certified right now to be trainers. So we can kind of help with all aspects of anything that you need there. You've got experts here that have years of experience with Puppet, so we've been around a lot with it. So with that, pass it back over to Chelsea.
Yeah, thanks so much, first off, Dan and James, for that awesome presentation and demos. It was really great. We did receive a few questions during this session, and if you didn't get a chance to submit any throughout, please feel free to do so now using the chat or Q&A feature on your WebEx dashboard. So with that, the first question we got is, how is configuration management different from writing my own scripts?
Great question. So with configuration management, one of the main ways that it differs is you're really thinking about the end state that you want to be in versus the process to get there. So when you are writing Puppet code, you're not thinking about, hey, what commands do I need to run? What exactly is the process? You're instead thinking about what's the model that I want this server to fit in. And so since you describe it in that state, you're looking at the end state. It's a lot easier to take more of an architectural perspective in terms of how you configure your systems. And you start there, and you can know that it's going to be applied every time in that consistent way, can be run over and over again, instead of normal scripts where you run it once, you kind of hope that you get the end result that you want, and it's maybe dangerous to run more than once. So that's really where it differs, and that's where configuration management can really help out.
Great. Where would you use Puppet versus SCCM for a Windows environment?
Yeah, that's also a good question, and one that comes up pretty frequently. So for looking at a Windows environment where you're maybe using SCCM already, it's already got a lot of features and capabilities within it. Puppet is really focused on a little bit of a different focus. It's really infrastructure as code, where you're going to be designing individual resources, building up that model like I was just talking about for how you want that system to be configured. Whereas SCCM is going to be a little bit stronger in terms of some elements like patching and things like that. So there's definitely room for both of them to coexist. And that's where we frequently see customers moving, where they might use some features of SCCM if they already have it in-house, but they still want the benefits of code design, code reviews, the workflow of infrastructure as code and model-driven development that they can use something like Puppet for. And that's really where our strength is. Great.
How hard is it to migrate from Puppet open source to Puppet Enterprise?
Yeah, so the great thing is Puppet Enterprise is built on top of a lot of Puppet open source components. We really just have a little bit more of a prescriptive workflow with that. We add a lot of additional features like the web-based console and UI on top of Puppet Enterprise, so a lot of reasons why people choose to go that route. But migrating between the two, it's the same code that's in the background running with Puppet Open Source and Puppet Enterprise. It's the same language. So ideally, it's going to be a process of just making sure that you're following our best practice for enterprise customers, that you've been using Puppet in a supportable way. So that's something that we have lots of tooling in-house with our professional services team to help you with that. Service delivery partners can definitely help you with that in terms of doing that sort of migration. But yeah, that's generally the idea. Same code in the back end, so it shouldn't be too much of an uplift for you.
Okay. Do you really need to have a source code system like GitHub or GitLab?
Yeah, definitely. So it's not something that's a hard requirement of Puppet that you have to have some sort of version control like GitHub in the background, but it's definitely recommended to see the real benefits of using configuration management like Puppet. Typically, you want to have tracked code where you're seeing kind of how your code is being developed, why changes are being made in your environment. That's really where you get a lot of your auditability as to changes that are happening. In addition to that, without that version control, you're just kind of having, people making modifications to how your system state looks without a lot of that same tracking that you have. With version control, you have easy ways to be able to see that history roll back if you need to previous versions of configuration. So we definitely strongly recommend it, even though it's not technically required.
That's a question that we get a lot too. A lot of companies have asked us whether they really need to have it or not. And one of the things that we typically see is once it's implemented, their whole workflow from developers submitting the code and flowing into Puppet and getting distributed. Code Manager does a great job of managing the code, getting it out to where it needs to be, and just making that whole process so much smoother. That once they kind of see it all working in action, it really kind of answers its question that it's almost more work not to use it.
Great. Those are all the questions we got. So I believe, James, you're going to touch on Puppet Camp again, or do you want to just recap quickly?
Yep. Just again, a call out to Puppet Camp. As I was saying earlier, it's really where everybody in the region can come together, just share best practices about how they've been using Puppet. It's great. One of the big things about infrastructure as code is you have the ability to share best practices with other users, share code, share implementations. And so we really highlight the strength of having a good community around this product. Can really bring a lot of benefits to your organization to keep you learning, keep you developing, and just keep you moving forward in your own environment. So definitely worth a check out. You can see the link here for how to access it. Check out the Puppet Camps local in your area.
And if you want to see a little more deeper dive on the vRealize automation integration, we'll be doing a talk at Puppet Camp this year, so showing more in-depth how you can integrate the two and manage your orchestration and kind of the behind the scenes of the demo we did with EC2 today. So you see a lot more details and get a lot more information on that as well.
And if you're interested in learning more about Puppet or configuration management, come to Looking Ahead. It's our annual event happening in June in Chicago, and Puppet will be both sponsoring and exhibiting at this event, so you can come meet with their team and with ours. Looking Ahead is the annual technology summit created and hosted by AHEAD to provide you with the knowledge, resources, and relationships needed to drive innovation in your enterprise. You can go to www.thinkahead.com/looking-ahead-2016 to register, and it is a free event, so everyone is welcome. And that's all we have today, so thank you so much for joining us. And then thank you again, Dan and James, for your presentation. It was really great. Please keep an eye on your email inbox for a recorded version of the webinar to come. Bye.